Right. And then, yes, what I'm going to do is, if you haven't have the prepared the um, your browser. So here I put in the chat the address where you have the link to the exercise. So last time we did a very simple exercise regarding preparing the data science ecosystem. So what you have to bear in mind is how to create a data collection. You saw that in Kaggle there is a notion of data lab where we manage, etc., data collection. So that's the important thing to consider with respect to Kaggle. Of course, there is Colab, but in Colab you do not have a data lab that maintains the data collections. So this is why we moved to the Kaggle alternative. We saw, of course, that it is, well, everything runs in an externalized manner on top of the Google Cloud architecture, and that it is possible to connect different clouds as we have been doing in the lab and in class in order to get data and to manage material. And then the other thing that was important to consider is at first well, you know Python, but then have an approximation into pandas, because many of the data collections that are available, and also given the type of algorithms that can be eventually used in order to process data, matrices are a very important data structure to consider. And pandas is an example of a library that provides facilities in order to deal with matrices, with tables. Another important thing that is to have a critical and visionary observation of the manipulation of tables in pandas is to identify, to associate the different operators with those that you already know in the relational data model. And an important, very important thing that you should be able to argue about is which are the differences between the fact of having relational solutions and operations. So I'm going to ask you to click on HO2, and I have to stop because I am alone today and there is someone in the door. So just give me 1 second. So, and well, if of course you need to enter, to log into your Kaggle account, and I need you. Let's see if you can master that. I need you to create a new notebook and associate the data collection that we generated to that notebook. So I let you do the thing. So I'm going to stop sharing in the meantime this whiteboard. Yes, please. In Kaggle. And you associate the data that we the data collection that we generated last time, that we created last time, to the notebook. And I'm going to share my screen. Screen. Right. So your Kaggle notebook should look like this. So, well, I named it, but you can name it as you want, remember. And then here, well, I have my data collection. Today I'm using my personal account, so this is why it looks a little bit different. But well, you associate your data collection, and when you do, you have to see here the files. And remember that you do that by clicking on Update. So while you're doing this, as we discussed last time, in order to do data processing in general, even if it's big, with velocity, with variety, with everything you want, and you want to process data, we saw that in order to answer questions that are modeling questions and predictive questions, that are those associated to data science, there are two main sets of tasks that we want to perform. The first one is getting acquainted with the data collections and preparing them in order to then apply some algorithm model, mathematical model, etc., in order to answer either modeling or predictive questions. And in all these tasks that we perform in both groups of activities, we can apply different tools. And particularly in data exploration and data preparation, descriptive statistics is almost, we can say, the tool in order to approximate towards the data collections. First, because as you saw, the results provide us with a quantitative profile of the data collections, and particularly it provides, this profile contains the mathematical properties associated to the values contained in the data collection. And since then, we are going to apply either algorithms or mathematical models. These mathematical properties of the data collection are necessary in order to decide whether we have to engineer the collection and prepare it in order to use a specific tool, and also to decide which are the tools that can be used in order to answer our questions. Okay, so today what we are going to see is that even starting with descriptive statistics, we can already perform and answer some research questions by just exploring mathematically the data. Okay, so this is the objective. So it is written there so that if at some point you get lost or you do not see the message, go back and there. So it says apply descriptive statistics to explore data collections and compute quantitative descriptions. you will see during the exercise that there is a lot of reference to statistics, and I'm going to explain in a general manner the concepts, and then we will do as in other exercises. You will have time to go back to your statistics fundamentals, and then complete some of the interpretations that are required in order to perform the experiment. So for the, are you watching my browser? Because in my second screen I cannot see it, and so I wonder whether you are looking at it or not.
Yes, we can see your WordPress.
Yes. Okay. Okay, right. So what we need is Jupyter Notebook Server. You already have it. We need some Python libraries. And what we're going to do is use a data set from the UCI's machine learning repository that gives, well, it's a collection about population in the US. You have the natural language description in number 4. Do not consider the section 3 to do and to hand in, because we are going to do the exercise together, so you don't have to hand in anything. We're just working on the lab. So the data collection has different variables. It represents information about people according to their age, their gender, marital situation, the country they come from, their income, and yes, their income, their education, their occupation, capital gain, etc. So attributes related to their economic status according to their education and occupation. Okay, so that's the content of the collection, and we are going to answer a research question. Okay, so everything we are going to do, you just have to bear in mind that is intended to answer the following questions: are men more likely to become high-income professionals than women? And we are going, first of all, to make a huge hypothesis, which is that we are going to consider that someone earns a high income when she or he earns $50K per year. Okay, so that's high income. Right? Everything clear? Okay. So I have, like on TV, I have prepared the notebook, because in that way I can explain while you are. So I'm going to go back and forth from this side to the notebook so that we can step by step run the experiment. So remember that at first we have this little code where we have the path to the right data. So do not forget that you have to complete it. In fact, we're going to use this one, the adult.data collection. So the first thing that we are going to do is open the file, and we are open it on read mode. Yes, I have a question, please.
Yes, Doctor, sorry for interrupting, but could you please share the link of the data, because I'm trying to access.
No, you have it on your Kaggle.
Is it the same as? It's
the
not
one
the
that
same
you
as...
created last time, yeah. So for instance, mine is called like this. Yours, I don't know how you called it.
What is it?
And
the one?
it's lying in your data sets.
Is it one of the countries?
No, you just you just connect to all the data stored in that folder, and that's it. There you have
Okay,
it.
thank you. Thank you.
Right? Mm-hmm. Here you see I have everything. Well, it's not a very smooth way of doing it, but it's a simple one. And since we are reaching resources, path.
Yes, thank you, Doctor.
It's fine. Okay, everyone has the data associated to the notebook, right? My iPad is gone. I cannot see what to see. All right, now it's back. Okay, so the first thing that we are going to do is we are going to open the file. Remember that the instructions are here, okay, in the link that I shared. We are in 4.1, so that you do not get lost with my back and forth activities. So the first thing that we are going to do is we are going to open the file called adult.data. Remember that you have to complete the whole path according to the Kaggle path that you have. And we are saying that we are opening it in read mode. And in fact, .data is nothing. So it's not an official format, but if you have a look at the content of the file, what happens is it is a set of record of attributes. Okay, and thanks to the data lab, we know how many records does it have and the type. Okay, so according to this piece of code, what it does is it processes the content of the file, and it creates a dictionary. And then what I did, this is Python, okay? This is not Pandas, this is Python. And so what I did is I'm just selecting 1 to 2 to have a view on a sample of records that we have created using this little piece of code. So if you run until here, you will see that we have records like this. So we have, well, some number. Oh, today it's horrible. 50, then the zip code, whether the person is married or not, etc. Just again, I'm going to, I let you do that. Today I'm not alone, so. Oui, c'est en premier. Pas de problème. Allez, passez la bonne journée. Okay, so the next thing that we are going to do is we are going to transform the data into a data frame. And we are going to name the columns in order to be more comfortable with their processing, okay? But again, remember that this is done by us. You can change the names of the columns. This is just processing and having a first approach to engineer the data so that we can be comfortable in order to explore them. So if you do that, and you observe only the head of the data collection, you will see this. No, so we have the age, the type of employer, I don't know what is FNI weight, education number, etc. So many columns like that. Yes, please, Mauricio.
Yes, sure. It's just that I'm stuck in the first part. It's just that I don't know how to put the file path.
Did you run this?
You can copy
Yes.
it from where it says
When
adult
you
data.
copy just until here,
Ah, okay, perfect. And also files, right? Okay, I think. Okay.
until files. Of course, you have a different name because your data collection has another name. You
Okay,
just
perfect.
before files and then.
Okay. Yeah. Thank you, teacher. Yes. Yes.
Right. Everyone on the same page? Do not hesitate to stop me,
Yes.
because I ran it before, like on TV. So, of course, now I can go very fast, but you are going back and forth. So I just do not hesitate to stop. Okay, so the first checkpoint is creating a data frame with data collection so that we can have a look at the first or a piece of a subset of records, and we can see what they contain. So just technical details. Note that when we do this print data, this data is not a data frame. This is a dictionary that we created by processing the raw data, and then it is only until here that we are really creating a data frame. And this is why we can have tail, head, and the other selection operations that we saw last session. Now, at this point, we do not exactly know how many rows does the data collection contain. So remember that with shape, we can know this. Okay, well, I didn't put it here, but that's a possibility. Now, the first thing that we are going to do is, yes, please, Mauricio.
Yes, sorry, teacher. It's just that a little bit because I'm like back and forward, and it's just that I don't understand the part where well, we first created a dictionary and then printed, and then the part I didn't
Well, we
understand
didn't
was the
print it. We
part.
printed a row.
Okay, yeah, we printed a row. Okay, and then in the part that in the next code, I don't understand what we did. I don't know if you could
We
explain,
created a
please.
data frame. We want to use pandas in order to
Okay.
explore the data collection. So we are converting the dictionary into a data frame in order to have a real pandas table with the name of the attributes that, well, I chose these names, you could choose others. And so that we can apply selections and projections smoothly on this data frame.
Okay, okay. Yes, I see now. Okay, thank you, teacher.
You're welcome. More questions? Okay, so now comes a kind of, again, you will see that we will be doing a lot of decision making with regards to the question that we have to answer. that has nothing to do with coding or whatever. It's just the flair that we have, and that we learn that this flair comes from our statistics knowledge. Okay, so if we want to understand whether men start getting high income before women or not, and we are seeing that there are different countries. The reflex, a statistical reflex, is that we cannot treat people coming from different countries in the same way. Okay, already considering that 50K dollars per year income is high income is a very huge hypothesis, because salaries and economic situations in different countries change. Okay, but anyway, so we did this very huge hypothesis on this. But then, anyway, we cannot treat people in the same way. So we want to know the distribution of the sample that we have here of people with respect to their countries, okay, in order to understand how many items, how many observations do we have in the example per country, and see whether we have enough data per country, or which is the country for which we have enough data in order to perform our analysis, okay? Because if we have 2 observations from China, well, we cannot, it's useful to perform statistics or whatever, because our results will not be representative and conclusive about a country if we only have 2 observations, okay? So a thing that we are going to do is we are going to group the observations of the data collection by country and see how many observations do we have per country, okay? And this is what this piece of code does. So group by, you know, because you are relational experts. So we are going to group by country and count the number of items that the data collection has per country. Okay, remember that when we do aggregations like size is counting, then we need to perform group bys. And well, we have this little variable here that contains our result, and so here I printed the result. And so what we have, well, first of all, note that the data collection is dirty. Okay, so this is the normal situation when we deal with data science, big data, etc. Many people say that big data is big litter, okay? Because since you get everything you observe, there goes everything, including litter. So for example, here we have an unknown country with a lot of observations. And then we have other countries that we know. Cambodia, 19, Canada, etc. We have Mexico here with quite a bit of observations, etc. The United States, of course, because the collection belongs to the States, so there we have a lot of observations. Yes.
Teacher, when you say observations, we counted the number of people, right? In that each country.
Remember that when that's something that we discussed last time, that the main difference between having classical queries and data science queries is that the data collection represents observations about an object of study. Okay, so every record represents an observation, right? And then we are, from all these observations, we are grouping them by country, and we are counting how many observations do we have by country. In technical vocabulary, how many records contain the same country, and we count them.
Ah, okay, I see.
Right?
Yes.
Mm-hmm.
I need to.
Yeah. Of course, that's an exercise that I have to do because I have to transmit this to you, is that every time, okay, in fact, we are moving from disciplines in computer science, okay? And so this is why the vocabulary changes. And so I try to use the right vocabulary so that you get acquainted with that. Of course, I could have said records and that's it, okay? But I am using observations because now we are moved into data science and records are observations. In fact, observations are modeled as records. Observation is a concept in data science, and then since we are using a programming language and data structures, so this becomes a record. But it's important that you bear in mind these two levels. Okay. Remember that you have to avoid at all cost to be monkeys. Okay. So technical, I mean, it's not pejorative. It's just that when we come to university, we learn a vocabulary, we learn theory, etc. And this makes a difference between investing in studies at the university or just having technical, very practical studies, short studies that let you perform something, but do not give you the general vision that can let you eventually, if data science changes, then go to other disciplines and address other problems comfortably, because you have a good basis, theoretical basis as background. So this is what you have to seek from university studies. Right, okay, so we observe this, very good. So that's, now we know who is who and how, which are the countries that are best represented within the data collection. So now we keep this in the stack. And then the other thing that we have to do is know the distribution of ages, since the research question that we are trying to answer is at what age women and men start having high income, earning high income. Okay. So the other thing that we want to know is, again, how to distribute these observations with respect to age, despite being man or woman. So here we have just a piece of it, but you know how to select the different records and observe within the records that are not provided by pandas here. So just having a look at this piece of observation, we can see that the observations start at 17 and end at 90. but that in between, for example, we have only one observation. I mean, the observations of the 80s are few. Okay, so now we know the countries, we know the ages, and now we are moving forward. Since we want to compare men and women, well, a reflex that we can have is trying to know how many men are there in the data collection, and how many observations regarding men are there in the data collection, and which of them already earn a high income. So we have 6.5K observations regarding men, and we have 15 observations regarding high income main workers, main professionals. And then we do the same. Yes.
Yes, sorry, teacher. It's just that so the first number is 6,600 is the grouping.
No, in fact, it's just the first one.
Is the
Okay,
first
it
one.
didn't.
Okay.
Yeah, let's divide it.
So there are 15 men that have an income.
Yeah.
Okay.
Right. And now it doesn't work, of course. Why doesn't it work? Because I didn't. No, because I didn't execute the previous ones. I can. Well, I'm going to run everything. Okay. We will wait for a while. It has an execution status. Now it's fine. So we have a look. We have 21 and more than a half K male. 15 is not that. 15 is just the shape. And we have 6.5K males with high income. And female is 10.5, and 1K high income females. Can we conclude already something about the fact that there are more men with high income than women? Is it possible to conclude now around this? Could it be pertinent?
Yes, we can conclude that there are more male that have more income.
No.
What?
No. Because all the countries are confused there. It's too early. We have dirty data. We are mixing all the countries. We just know that within this observation, within this data collection, we have observations regarding women with high income, much fewer than those regarding men. But this doesn't say that we can generalize. Right? We
Yes.
have few knowledge for now. We will eventually try to acquire more knowledge, but for now, there is too few knowledge about the data so that we can conclude something. Right? So it's just, we're just approaching and knowing what does the data collection contain, but no conclusions for now. So in order to start, again, having more, a better approximation to the collection, we are going to talk about percentages. So in statistics, that's something that we learn. If you just count, you lose the portions of your observations. Okay, so in fact, what is more represented, more conclusive, is to know what portion of your inhabitants is high income or less income, or women and men, because otherwise you would be comparing peers with apples. Okay? Imagine a huge country like the US, you will have a lot of observations, but this doesn't mean that you can compare it with El Salvador, for example. It has fewer inhabitants. Okay, but if you think about the proportion, there you can compare half of the inhabitants of the US against half of the inhabitants of El Salvador. And even there are other things to consider, but there you can start trying to compare. This happens in the pandemics. You said in the news there are X millions of deaf people in the US or in Mexico against much less number of people that passed away in France, for example. But this is not conclusive, because the number of inhabitants in France is much less than the US or Mexico. It was useful because in that way we have fear, and so we started protecting us. But in fact, this is not the right way of comparing. There were other comparisons, and we know that the situations were very bad in the US, Mexico, etc., but not with respect to the counting of people. Okay, so for the time being, we know that the rate of people with high income in the whole set of observations that we have is 24%. It's anyway few, and that men with high income is 30% and women with high income is 10%. Now, in terms of data science, an important thing that would have let us start concluding something is if we have had the conditions in which, information about the conditions in which data was collected, okay? Who decided where to observe? Was it because women didn't have time and didn't answer a questionnaire, or was it because normally in companies there are, for example, in tech companies, there are more men than women, and this is why there are few observations about women? Or is it because it's like Cinderella, they hid them in a room, and so only men answered the questionnaires, or which were the conditions? Okay, so that's very important when you perform this kind of exercise. But anyway, we can continue. This is a repetition, so yeah, I just did it twice. Now we are going to, okay, let's accept that our reality is the sample that we have, okay? So anyway, we know that there are less of information, there is less information about women, but in the proportions that we can observe, still those men that have high income the proportion is higher than those women in the reality of the data collection. So now, since the research question was regarded age, so let's have a look at what is the average of age in men and women within the mean of age of men and women in the collection. So you see, we are just playing with pandas. Okay, so two simple tools, pandas as data structure with the associated operations. So we have here projections, and we have aggregations, and we have been playing with group by in order to select and organize the groups of observation that we want to make. So men is 39, almost half and a half, and 36. So officially, these are young professionals. And then we can see, so these were men and women. So men, the average is older than women. And then we can have a look at the age in which they start earning high income. So you see, men is 44 and women is 42. So within this observation, women start earning high income younger than men. In my notebook, there are no explanations about the measures. In the notebook that, in the exercise that you have here, at some point, we have these explanations that let you remind a little bit about, one, the principle that was considered in order to decide to compute these measures and not others. And also the critical observation at some points of the results. Okay. Again, today we will just have a superficial explanation of this in order to really understand and interpret the results that we are obtaining. We have to, we all have to go back to our statistics course and remember the principles of sampling, the principles of, for example, here the concepts of population mean and sample mean are important, and you shouldn't confuse them in order to provide interpretations of of the results. Because otherwise here we will, I mean, if we are feminists like I am, we will start saying, yes, things changed because now women start earning high income before men. Good thing. And in fact, no. So we should remember these kind of concepts in order to moderate our joy. So what statistics says is that mean is not a very representative measure, particularly when we talk about samples and not populations. And in fact, what we would like a more representative and conclusive measure to be considered is variance. So what variance and of course standard deviation. And so the next piece of code, what it does, it compares, in fact, the average, the variance, and the standard deviation of the observations of regarding age between men and women. Okay, in order to modulate this fact that women start earning high income before men. And so you have the variance, which is not a big deal. And then it goes, the analysis goes further and wants to observe the hours per week that men and women work with regards to the average, to the variance, and to the standard deviation. Now, why? Because the person that designed the experiment considered that it is not only the fact of earning high income, it has also to do with the amount of energy that you have to invest in order to earn high income. Okay, so if I have to work 20 hours per day to acquire a high income at 39, this doesn't mean that my situation is an ideal situation. In social conditions, a real valid situation would be that working 40 hours per week, in the case of Mexico, because for example, here we work 35 hours per week, okay? But in Mexico, you work 40 hours per week, so working 40 hours per week, at some age, let's say 42, I start earning high income. So this is this says something about privileged situation. Okay. So now you want to come to work in France because we work 35 hours, and we have a lot of vacations.
Doctor.
Yes.
I wanted to ask a question. So, like, can we make a proper like analysis or conclusion from our data? Well, I was thinking mainly because, for example, if we check how many like data points, I don't know how to say it, like for males and females, I think we have way more entries about males than females. So if our
Exactly.
yeah, that was my
And
question.
this
So
is
if
why
our
we did the proportion.
okay, the
Yes,
proportion being
otherwise,
yeah, I hear you.
do you remember here at some point we, yes, here,
In the
you
rate.
know, we did the rate
Okay.
because of this, because at the beginning, when we started having a look at the data collection, we saw that anyway, comparing men and women like that was not very clever because we have more men. So, firstly, there would be a bias with regards to the conclusions that we have for men and for women. So
Yes.
this is why we started doing the rate in order to reduce this possible bias of the observations.
Okay, but at the same time, like I'm not trying to discredit because I know that the
No,
gender
you can
gap is
discredit anything. I didn't do this.
no. I'm not trying to do that. Like the only thing I'm trying to say is that couldn't also be a sampling bias. Like if we have
Of
a smaller sample of data of women, like couldn't it have like a bias because of the sample size?
Of course, we have a sample bias coming from the initial data collection. And this is why I came up with this idea of the conditions in which this data was collected. Because the first reaction that we should have is yours. Okay, we have less women, but less women, why? Because the collection is incomplete. Then some in data engineering reflex could be to try to balance the
Yes.
number of, but the problem is that how are you going to do that? Are you going to exclude some observations regarding men? Or are you going to artificially, synthetically generate observations about women?
Oh, okay. See.
And this is a practice in data science that comes from statistics. In fact, today there are people working on the generation of synthetic data in order to complete data collections, because data collections completeness is an issue in data science. Of course, there are a lot, and Kaggle has a lot, and everyone shares a lot of data. But if you really go to see the data, you have a lot of problems like ours. Then you have a look at the categories of the observations, and you see that the categories are not properly balanced. And what people do is they want to do anyway analytics. Okay, and what they do is they try to figure out techniques in order to complete. Of course, there are the mathematical techniques that we all learn in our studies, which are doing, for example, interpolations, extrapolations in order to complete and to generate more data. But then there are other people applying artificial intelligence solutions in order to see the observations as a phenomenon and then try to predict which values would belong to these observations. And they
Oh,
validate
okay.
and they run, you see, and then if a lot of French women professional situation looks like that, then which would be a representative synthetic women situations that would belong to the reality of the observations.
Oh, I see. I see.
You
But at
see?
the same time, like the fact that you have less like data from women, it could also suggest that maybe like there's an inequality in that sense, right? Like there's a lot of more men than women. That could also be like a part of the problem at the same time.
Yes. And that comes from, this is why data collection strategies come from statistics and also from social sciences. So this is an example of a social sciences problem. So what we would have to do is adopt a non-biased data collection strategy. But this goes to the data collection strategy. Here we forgot about it and we got the data.
Yes.
Then you would have, for example, to either collect less data from men, or think about proportions. I'm going to collect data, I don't know, 50% of men and 50% of women in a company. And so from the beginning, I know that I decided per proportion to collect the data. But this is not the case, okay? This data,
Yes.
I think that
It's
they
very...
just... mm-hmm.
No, I do want to say that's very interesting. All this.
Yes.
Thank you, Doctor.
And this is why these type of queries are much more complex to address, because there are many hypotheses, many situations that have to be considered in order to answer. And so at every point here, I'm not, I'm just introducing the pipeline, but in fact, for every decision that we make, we should evaluate scores, for example, the degree of error, including the collection of data. So to which degree to which extent is my data representative with respect to the US, for example, society? And someone would have to estimate this degree of error in order to mark this as part of the metadata related to the data collection, and so on and so forth at every situation and at every decision that we make.
Okay, I understand.
So that we, so that we calibrate the results.
Thank you, Doctor.
You're welcome. And this is why data scientists are looked for today. You see, you have to do this all the time. It's a very rigorous thing. Right, okay. So we decided then to have these variance and other statistical measures in order to have a better understanding of the observations. And then what we can decide is observe the ages. Now that we know more or less about the ages, try to identify the median of male and female ages in the data collection for both the groups that we have done. So in general, all female and women, male and females, and also with respect to high income and low income. Okay, so we have the median age per women or men, because again, the problem there with the fact that there is a difference in the moment in which women and men, according to the observations, start having high income, has to do with the distribution of the ages. You see, it's not only the fact that we are observing male and female communities, but it's also the fact that we are observing different ages. And from the beginning, we knew that the ages distribution was very poor. It was skewed. So we observed the median age per men and women, and then the median age per men and women regarding the high income. And then also the median regarding the number of hours that men and women work. And this is because we know that data is dirty, that there is bias within it. And so we, despite this problem, we are trying to figure out whether we can still drive some conclusions. And this is why we're doing all this. Okay, it's just exploration and understand. And then, since I was talking about distributions, what is also possible to do is think about quartiles and percentiles and try to group the observations with respect to these concepts and start trying to understand data distributions, and this can be done by plotting. So this isn't close. So I'm going to run mine all together, because since I'm talking a lot, so I let you run yours and start producing your nice plots. You see, this is in a visualization what we were talking about. From the beginning, you see the data distribution is skewed to the left. So for example, what happens with this? Do we keep this, or do we do some sample in the sample in order to do not consider these observations that are just perturbing our conclusions? But for the time being, at least, it's just exploration, so we know that it's skewed to the left. Regarding age, then we can go and see the distribution of ages with respect to women. Of course, we keep the same problem because, I mean, the whole thing is already skewed, but we know, for example, that there is a lot of observations regarding women are within these ages, you see, between, well, a little bit before 20, because we know that it started at 17, and then to the 40s. And here we are going to use another visualization library, which lets us produce like more fancy plots. And here we are having a look at the distribution regarding the distribution of ages, but by samples. Okay, so we are dividing the ages by samples, and then we can see, well, the rose one is the one that we have more or less here. No, it's not that. It looks like, but not. Anyway, it maintains, these are the quartiles and the etc. But here we see that anyway, the most representative observations that we have are in this zone. And then with the real distribution of those ages in a more in a less aggregated manner. So it's the same observation, but with this is huge grain and this is low grain. Okay, the blue one, the one that is more like behind, is the same observation but in a fine grained manner, and the other in a more big grain manner, and always male and female. And I excuse myself of the fact that I am using blue and rose for this. Now, of course, you have understood that, I mean, defining the commands in order to perform this is not a huge challenge. The question is, if I start from scratch, is it possible for me to develop this pipeline of tasks in order to observe and to explore my data collection? If this is not the case, what do we do? Well, in fact, data science is a multidisciplinary science. So this means that we have to work together with a statistician, for example, in order to let the person help us with regards regarding the exploration on the different strategies that statisticians master, and then combine this knowledge with our technical knowledge, and then produce the right experiment. And also, that person would help us calibrate our conclusions. So this regards age, and then PMF that I'm going to let you remember. The explanation is here, and we will. I'm going to go through the experiment, and then next class, as we did in other classes, I'm going, but it will not be you, but me, that will give you some insight on the decision making that was made regarding statistics in order to wrap up everything and have an X-ray of the experiment. Okay, so probability mass function is a function that calibrates the observation of the distributions of the samples, and this is what the experiment uses in order to compare the graphics and compare the distributions between, again, always, since we are comparing men and women, that's what we are doing, and of course calibrated with respect to the age, because this has its importance in the answer that we want to drive regarding the research question. Then the experiment will go further and do plots regarding cumulative distribution function in order, for example, to compare the age with this function that will aggregate the observations and start solving the skewness of the distributions. And this will happen, of course, for male and female samples. This looks like this. Like this for male and female. And then the cumulative distribution function. And this is, again, to reason about this problem that we have here. This is a problem. We have to decide what to do with these ages that are there perturbing our conclusions, but that we cannot just cut brutally. So all the, this is a repetition. So all these comparisons, in fact, are trying to give us arguments in order to decide what to do with this. Either explicitly by modifying the data collection, or either for calibrating the conclusions. Okay. And here again, the comparisons. Now, until here, as I said, we are observing the problems, but we are not making decisions. In order to make decisions whether to reduce the sample and just gather those data that are representative and that are not skewed, etc., a very important exercise in data exploration is dealing with outliers. Okay. In fact, what happens, for example, if you observe here, is that these observations, starting more or less on from almost 70 to the 90 years people age, these are outliers. Okay, so they and they are perturbing our observations, and the question is, what do we do with them? Okay, so the exploration must include the observation of the outliers and then a decision in order to cut them in a way or in another. Did you have information retrieval a course on that? Do you remember the Loon distribution in information retrieval?
Doesn't sound familiar to me.
No? Well, in fact, this was just to try to associate it with this distribution problem. In information retrieval, you remember that what you do is you process the documents, the terms of all the documents of a collection that the crawler crawled. And but the documents, and then you do semization, etc., and you keep terms that are that you exclude the terms that are that come a lot, like prepositions and etc., and those that are very rare, and you keep those that are in the middle. But then if you study the distribution of that, you will see that there is a curve of representing the distribution of the terms used in a collection of documents. And the question is that you cannot keep all the terms, because this is not strategic. And the question is, which are the terms that you are going to cut? And in fact, what happens is that Loon was a person, a statistician, and he said that, in fact, the representative content of any document are the terms that are in the center of the curve. Okay, and so all the terms that are out of the center of that curve, you eliminate and you do not consider in the frequency matrix. Okay. So this is the same case here. What are we going to keep in our result? Are we going to cut, for example, here? Or are we going to still consider these people here? And again, these are too much people and too young. Are we cutting them? Are we just keeping those here in the middle or not? Or are we going to make the distribution smoother? And once we will have made the distribution smoother, we will cut in the center. Huge decision. In order to make that decision, we first have to deal with things that are perturbing, which are the outliers. Okay, so in the case of information retrieval, this is why we do not consider adjectives and prepositions and nouns and pronouns and etc., because they will be too representative. So either those that are too representative or very lowly represented are perturbing. But again, we have to provide mathematical arguments to our decisions. We cannot just cut like that. And this is why this part of the experiment goes and looks for these outliers. And then here, as you can see, it starts cutting, in fact, the median plus 30. And again, are you going to cut with respect to the actual values, or are you going to cut with respect to the median or the standard deviation, or etc.? So here the decision is that you cut with respect to the median plus 35 and minus 15 is those that you are going to exclude, and in order to keep with those values in the middle. And so again, a lot of, and then you have to reason. The thing is that our problem is multidimensional. No, we have the gender, we have the age, and we have the income. And for every variable, we have to do the same reasoning. Okay, this is why it is very verbose. And so this happens in these lines. You see, and then here you start having a look at the outliers. And of course, we can plot, you see. Now, a very important question is which are our outliers and which are not. Okay, so here, since this is not a data science course, we are not going to go into details of that. But again, as we discussed with respect to completing the data collections, again, in order to really understand and dig into the matter and decide which are outliers or not, there are statistical and artificial intelligence and machine learning techniques in order to decide which are them and how to solve the problem. But do not get scared. We're not going to go into these details. We will remain computing systems engineers, and we will do other exciting things. This is exciting, but it's just that it's another discipline. And so again, you have, now you can see the difference in promoting men and women. Then here I have a problem because this is not text. I might mark like text. So here it continues going into the observation of skewness. Then it applies the Pearson's coefficient in order to have a more precise observation of the populations. And then again here, when you decide to start really extracting a subsample of your sample, you are starting to do not data exploration, but data engineering. Okay, and again, this belongs to the first part of the preparation of the data. Okay, so data engineering is a part of data cleaning. You start getting rid of what doesn't help with good arguments, and then you make decisions. Now, and this is what is happening here. I'm not going to go into details because you will have to see this on your own, and so that next time we can conclude on the observations and arguments that we have. So again, a lot of things, then a lot of distributions again to engineer the data until at the end, once you explored and you understood the distributions, having got rid of the outliers and of the skewness, etc., then at that point you can have some arguments in order to drive your conclusions. And what we will do is that, as I said, you're going to complete the exercise, and the only thing that you have to prepare for the next lab is your conclusion, the answer to the question. Okay, so can we conclude that there is a difference? At what point do women and men start earning high income, and what can be the answer to the research question out of the observations that we do in the experiment? Okay, so that is the only thing that you have to prepare for. For the next lab, we will wrap up with the pipeline, and then that will be it for data science. We will stop there, because now what we are interested in is, let's suppose that someone else, an applied mathematician or whatever, did the experiment, I mean, designed the experiment, and now our problem as computing systems engineers is, how do we deploy this in a target architecture so that it can run, that it can accept more data, that it can scale, and that it can be useful in real conditions, because these are in lab conditions. Okay, so what our role as computing systems engineers is scale and put it in real, and how do we deal with jobs, etc., in order that this can run in industrial conditions. Okay, and this is what we will address, in fact, in the remaining sessions of the lab. Okay, questions?
Doctor, so you said that we only need to answer, but do we also need to answer the questions that you have on your page?
You need to answer them. Yes, you need to answer them in order to drive the final conclusion.
Okay. Okay. So we follow. So we follow the activity. We answer the questions, and then we answer the final. Perfect.
Yes.
Perfect. Okay.
Right.
Yes. Thank you.
Very good. Okay. Other questions? There are two things that I shared in Slack. One is these are two messages from the university. One is regarding a tutorial about argumentative reasoning. If you have time to go and see, go, because it's an argumentation technique that you can apply to engineering. So that's one thing. And the other thing, due to the 8th of March, there will be some keynotes and discussions on on gender balance issues, and this is not a question of only of women. Men are considered there because you are harmed by the patriarchal society too. So if you have time and have a look at those issues, do not hesitate. This is because these are people that know about gender balance in a scientific manner. So the discussions are not just coffee discussions. These are interesting to follow. But anyway, the one about argumentation is a very good thing to follow. Okay, so if you do not have more questions, we can conclude here, and I'll see you on Friday.
Thank you, Doctor.
You're welcome. See you. And I'm going to stop sharing and recording.
Thank you, Doctor. Have a nice day.
Have a nice day too. Bye-bye.